Graphing and shading inequalities. I'm going to start with the top one, and I'm going to do it in red. If you have a less than or greater than, you're going to graph with the dotted line. If there's a line underneath, like less than or equal to or greater than or equal to, we're going to graph with the solid line. So let's graph the first one in red. My y-intercept is -1, and my rise is 2 over 1, so I'm going to go up 2 over 1, up 2 over 1. And I'm going to graph this one with a dotted line. And what I like to do is I like to draw a little stick figure. So my slope is going up. If it's greater than, we shade above his head. If it's less than, we shade underneath his feet. Since it's pointing to the left, it's less than. So I'm going to shade this area right here. Now I'll do the blue equation. I'm going to start at +1. I'm going to go up 1 over 1, up 1 over 1, and I'm going to graph with a solid line. So when I shade this one, I'm going to shade less than as well because it's pointing to the left. And my solution to this is anything that's overshaded. So the pieces where they overlap looks like right here. So this part in green will be the solution. Now anything in this can be the solution. So if it asks you, find a point that's a solution, you could count over 1, 2, 3, 4, 5, 6, down 5, somewhere there, and you could say 6, -5 is a solution to this graph. It has to be anything in that green area, and there's an infinite amount of solutions. Here's another one. So if I'm going to graph this, the first thing I'm going to have to do is I'm going to have to solve or get y by itself. So I'm going to subtract x. That cancels, and y is greater than or equal to -x plus 3. So at +3, I'm going to draw a dot. So -x, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. Because there's a line underneath, I'm going to draw a solid line. Again, draw a stick figure furthest to the left because that can help. If I read this statement right here, y is greater than means I shade above his head. So anything in this area right here is a solution to my graph. If you have to pick one, then you could pick 1, 2, 3, 4, 5, maybe 2, and you could say 5, 2 is a solution to this graph. Another way to prove it algebraically, there's my x, there's my y. If I plug it in right there, then I would say 5 plus 2 is greater than or equal to 3. Is that a true statement? Is 7 greater than or equal to 3? Yes, therefore this is a solution.